All right, so it's Tuesday. Geez, oh man, welcome to IAEI News Live. I had a phone call and discombobulated me, but wasn't prepared. Anyway, was trying to get prepared, but anyway, so today's Tuesday. Today is Tech Tuesday, and I have to make sure that, because I wasn't doing what I was supposed to be doing beforehand, and I am. All right, so we're good. So today's Tech Tuesday, and today's topic on IAEI News Live is focused on receptacles. So we're talking from the old type of receptacle to the newer type of receptacle to receptacles that have so much technology in them that it's just crazy, absolutely crazy. And they went from something that was this deep to something that was this deep, much more complicated. But in any case, we're going to talk receptacles on IAEI News Live, and it all starts now. All right, welcome back to yet another IAEI News Live. I don't know about you, but I'm telling you that there's just a lot of opportunity all around us for educating on some of the most simplest of items. You would think that a receptacle is something that is like a no-brainer, right? Just one of these things that it's just a receptacle. But I think, in my opinion, when you look at the journey that a receptacle has taken over its life from something that was very simple, that just had a hot and a neutral. Think about it. That's all that is on this receptacle is a hot and neutral, and all you got there is two blades. There's no equipment grounding conductor anywhere on that receptacle. So, Larry Griffith, good morning, good afternoon. It was a rough start to our little program here today, but we got it done. So what I wanted to do was, now the audio should have just changed, should sound a little bit better, because I moved over to my Rode microphone. All right, so you take a technology like a receptacle, and when you look at that device over its life, on how it started and where it is today, it's another great picture of how technology has evolved to a point that you can insert the technology into a device as small as a receptacle. From adding ground fault circuit interrupter protection, where you have your push to test buttons, tamper resistant, equipment grounding, nice green screw there, and the technology from wrapping the conductor around the lug, like that's there, to pushing the conductor into the back, then screwing down the screw to put tension on that termination. This isn't a backstab. It is a backstab, but it is actually being held in there by a screw. So for proper torque. And then you get guys like this that enter the market, right? That basically take the concept of a receptacle and make it to address those tight spaces, like ceiling fans. And I know many of you out there are watching this There was another live, Nihad. I hope I got it to the right live. I hope I didn't do it again. Oh my goodness. Hold on, Nihad. I am going to go to IAEI International. Yeah, the receptacle. I'm there, 7 watching. All right, we're good. Perfect. So, so we've taken receptacles to a different level, right? Now, I put some links in the I put some links down in the chat box, or not chat, but in the description for this event. And there are a few documents in there that are some, I think, some decent links that you should have available in your resources. One of those goes right back here to Product IQ. I called it Product Spec, but it's Product IQ. And you go to ul.com/PIQ. That's right, Jody. It's not your mom and dad's receptacle anymore. You go to let's do that. I'm going to do this right now. I'm going to see if I can. www.ul.com/PIQ. And let's see. And that's not the right display. So let's do this. I don't know why it does this, but it does, darling. So monitor 2, let me turn it off and turn it back on again. Let me go back to properties. Got display capture, boom, boom. And I hit OK. No, it's just not liking monitor 2. All right, so, oh, I know why. That's application. I have to go to display capture. There it is. All right. Jeez, oh man. All right, so when I go to Product IQ, if I go to, I have to log in, and I put my credentials in, and you're going to search for RTDV, RTDV. All right, so RTDV, and what you'll see is guide info. So you'll see receptacles, RTDV, guide info. And what this does is it gives you all of your different types of all of your information for the proper application. So when you think about what's here in Product IQ, put your standards hat on and think that, hey, David Englehart's in the house. Lighting outlet receptacles, yeah. Where'd it go? There it is. That's this thing here, right? This is a lighting outlet receptacle, but for like a ceiling fan, or you could put anything, any of those types of components in there, like whether it be a sconce, wall sconce, ceiling light fixture, just makes life a little easier. And they're weight supporting. They call it a weight supporting WSCR, something like that. They added some new definitions. But anyhow, so when you look at Product IQ, you've got to put your standards hat on and think about the UL standard for these things we call receptacles. And what UL's done is tried to pull out in a free format, so it's all free. This is not something you pay for, but it gives you the information you need for the proper application of the device. So as you'll see here, it says general requirements, the category, this category, which is RTDV, and there is no rhyme nor reason on the acronyms. So don't try to say R is receptacle, TD is for Tom Dimitrovich, and V is for, I don't know, victory. No, it has nothing to do with that. Okay, so the category covers the following: attachment plugs, receptacles for plugs and attachment plugs, stage type receptacles, combination receptacles with switches. And you've seen those. I know you've seen those. I know I've seen them. And if I've seen them, everybody's seen them. Those with switches, you'll have the receptacle and a light switch, toggle switch, so to speak. You have utility service receptacles, etc. You have your appliance equipment or fixture outlet. The receptacle is a female contact device intended to be installed on a wiring system to supply current to utilization equipment. And it says that the category may also cover the following types of non-standard configuration, blade or slot configuration type. Other similar devices are covered under attachment plugs, fuseless, attachment plugs with switches, and attachment plugs with overload protection. And they have the category codes there that you can click on. The attachment plug is a male contact device for the temporary connection of a flexible cord or cable to a receptacle, etc. Cord connector, a female contact device intended to be wired on flexible cords. And then you have your male inlet, motor attachment plugs, etc. So then you have ratings, 600 volts or less. Now you'll see on a receptacle, now on this receptacle here, I'm just looking at, there's the ampere rating, and I'm looking at the strap, tells you what your hot wire is, where your neutral is. There's a strip gauge. I love it. They tell you how much insulation to strip off of the bare copper conductor. You have your 15, oh, there it is. Right on the front, it says 125 volts. I don't know if you can see that, but it says 125 volts right on the face of the device, right here. So you know it has a voltage rating, and you don't apply these above their voltage rating. Devices have other voltage ratings are tested on circuits involving full rated potential to ground, except for multi-phase rated devices. It talks about not for current interruption, not intended to be disconnected while under load. They are intended, so devices that are marked not for current interruption are not intended to be disconnected while under load. They are intended to be installed in series with switches or other appropriate disconnecting means. That's important. You know where we see that? We also see that. I have the same wallpaper. Oh, on the computer. Yeah, that's a MacBook Pro. Yep. So another place we see this label of not for current interruption are on your PV systems, where you'll have a interlock for daisy chaining the PV modules, right? And they'll tell you that is not rated to be opened while current is flowing. You're supposed to isolate it and then disconnect it. So same thing here. Then you have your terminals. The terminations of devices intend to be wired to flexible cords are based on the use of flexible cords or cables. Terminations are very important. You know why terminations are very important? Because you want to avoid this. This is what you want to avoid. You don't want to avoid having the plug melted directly in to the receptacle. Now, I had a complete collection of these. People would send me their receptacles as they found this type of activity going on. And it was disturbing. Now, this one came with with an actual letter from the person who sent it to me, which was Mr. Gazdecki. He said, Tom, this overloaded on a refrigerator. So this conductor was connected to a refrigerator, and the root cause was loose screws. Now, when I rode, I think I drove him to the airport or something, because he says, thanks for the ride. Either I drove him or I paid for the taxi. I can't remember. But in any case, he worked for the same company that I did. And he was moving. So they were moving him from one location to another, and that's what was prompted him to remove the refrigerator from his garage. It wasn't because he smelled smoke. It wasn't because he figured there was a problem. And this goes back quite a few years, early 2000s, I would think, somewhere in that ballpark. So maybe about 15 years ago. Well, it's 2023. Holy cow. 2023. Yeah, it was a long time ago. So, so he was moving, and so he pulled the refrigerator out, and he said he could not pull the cord out. And then when he started looking at it, he realized the cord was melted into the receptacle. So he cut it out, and obviously he sent it to me because I got the letter and I got the receptacle. So you don't want that to happen. So you've got to make sure that you follow the torque requirements, and these devices, in many cases, tell you the torque either in the instructions. So this one says, this one, the information for torque will be in the instructions. So there's no torque values. There's only so much space on these devices. So don't throw the instructions out. My gosh, you got to keep the instructions. In fact, let me take a look at this one. Well, this one won't have. So now this one's different, and it's different for a couple reasons. It's because it's got wires on the back. It doesn't have terminals. I'll put this back in the box. So give me a break here. So this one doesn't have terminations in the back. It has a stranded conductor, okay? And they look like they're tin coated of some sort. But this has a stranded conductor. It does not have a termination. Look, there's no terminals on this. So when now in this case, the manufacturer ships the wire connectors with it. But you've got to think about the proper on how do you terminate these wires together. In this case, you're going to have a stranded conductor. You need to mate that with the bare copper conductor that you've installed, probably NM wire that you've installed inside the dwelling unit or commercial building or wherever it's at. It's probably not going to be a stranded conductor that you're pulling. So the terminations are going to be via a connector that you're going to have room for in the box. So I believe in some cases, you're really going to have to think about the depth of the box. And I know there are shallow boxes, depending upon the wall, depending upon the application. You may not be able to fit a device like this in some of those boxes. So you've got to think about box fill. And you've got to think about these wires. How much lead length do you leave on there? Because remember, you're allowed to make these shorter. And then you need to pull the wires out, make the termination. In this case, the manufacturer provides these little puppies. All right. And I don't know if they're marked. I had glasses. I have glasses. Oh my gosh, they're right here. I have glasses. I needed my glasses to find my glasses. Larry Griffith, switching bedroom receptacles. Yes, you can switch bedroom receptacles, but not with that built in. So this says on it, I'm gonna have to open, I don't wanna open this. This is like, you know, this is like mint in the box. So when I'm like 90 some years old, this will be a collectible and it'll probably be in the museum because they're gonna say, this is how we used to do things. And it says P4. I see a UL label, I see a CSA label, and I see a P4. I don't see anything around the outer edge. Okay? But what is nice about what some manufacturers will do is when they include those types of things for connections in the box, use them. And here's why. Because they've done the homework. The proper termination. You don't have to look at the wire connectors and determine, can it take a stranded to solid, etc. Is it listed? All that good stuff. So just, and don't forget to follow manufacturer's instructions. Those are your terminals. Unless stated otherwise in the individual product categories, the termination provisions of all other devices are based on the use of 60°C insulated conductors in circuits. All right. And the use of 75°C insulated conductors in circuits rated more than 100 amps. Well, that's interesting. And let me show you this. So it says, unless stated otherwise in the individual product categories, the termination provisions of all other devices are based upon the use of 60°C insulated conductors in circuits rated 100 amps or less. Now, does that mean you can't use a 90°C insulated conductor and land it on these devices? In my opinion, no, it does not mean that. So when you think about a conductor, oh my goodness, I gotta look. I gotta look in my little drawers of goodies to see. I believe I had NM wire. Oh, I do. Thank you, Peter Grazier, for this little guy. Although Peter, oh man. Where's my glasses? Jeez, oh man. All right, so this says, Peter, I'm sorry, buddy, but the sheath doesn't have the information that I need. So what I've got to do, I am going to have to push the conductor out a little bit. All right. I'm going to push this puppy out and I'm going to see if is it labeled. And it is not. But in any case, when we talk about insulation ratings, whether they are 90°C or 75°C or 60°C, we're talking about the covering on this conductor. The mass or the size of the conductor itself, which in this case is copper clad aluminum, okay? But if whether this would be, this is a solid conductor. This is a solid conductor and it has a 90°C insulation on it. I can land a 90°C insulated conductor on the terminal, but I cannot use it at its 90° ampacity. Why is that? Is it because the conductor is limited? No. It's because of the device. It's how the device is tested. So I'm just looking to see if there's any marking on the back of this one. This tells you line and load. This tells you some patent information, and it gives you a strip gauge. It gives you that it's 125 volts, 60 hertz. Tells you to see the instructions. Oh, it tells you the size of conductor for stripping the different conductor sizes. But the rating, the temperature rating of the device is going to be in the instructions. Same on this one. Same on that one. So let me take a look at this device. Well, this is the USB, which has, oh wait, this has, yeah, this one has the, doesn't have a termination, doesn't have a terminal, it has these wires. So these are 105 degrees C conductors. So in any case, copper, aluminum, no aluminum. All right, so the terminations are important, and the insulation rating, when they talk about the size of when they talk about the insulation rating for the size of the conductor, it's all about the ampacity. So I would have to select a little bit larger of a conductor if I'm at a lower temperature rating, which gives me more copper to wick off the heat for the temperature rise tests that are a part of the UL standard. All right, so, and the other thing it tells you is that even if, you know, your circuit breaker is rated for 75 degrees C, if you're landing on one of these, which is only rated for 60 degrees C, and you're using a 90 degrees C conductor, I can't use the 90 degrees C column only if I'm doing the adjustment factors, but I can't use the ampacity at 90 degrees C. I can't use the ampacity at 75 degrees C, even though it's on my circuit breaker that way. I have to go to the weakest link, which would be the device, which is only 60 degrees C. Does that make sense? Right? And if you look at the ampacity columns inside Article 310, you'll notice I can put less current at the 60 degree C rating is less, or ampacity is less than the 90 degree C. So if I need so many amps and I'm following the 60 degree C conductor ampacity column in that table 31016, then I'm going to be using a larger conductor for my load, which puts a larger conductor on the receptacle, which puts more copper or copper-clad aluminum on the receptacle to help it run cooler. Remember, that temperature rating of the equipment is all about temperature either at the terminal or in the box. And remember too, there's no circuit breaker here. This device here doesn't have a set of contacts that, you know, these wiring devices don't have contacts to open and close things. There's no overload in here. There's no overcurrent protection, yet it still has a temperature rating. When you look at the adjustment factors needed, these devices for temperature makes a big difference. Now, these will be rated for continuous duty, right, at their ampacity, so you won't have the 1.25 factor, but you still have to adjust the conductor size to a larger conductor because of the temperature ratings of these devices. All right, so okay, let's look at, usually they tell you related information. There it is. So if you go to the related, I was in the document, then there's related information. You'll see that UL 498 is the standard that receptacles are addressed by. So this is the UL 498. It's on edition 16, attachment plugs and receptacles. You have all of the different types of documents that are available, summary of topics. You can learn more about the standard itself and any other, if there's any other reference standards. You can review the comment, the scope. So if you want to see the scope, you can access the scope. Tells you the requirements do not cover devices rated more than 200 amps. Devices produced integrally with flexible cords is UL 817. Current taps and adapters not provided, 498A. Devices employing male or female screwless screw shells, 496. Devices solely intended, UL 1682, 1977, etc. So all of these products, all of this gives you the scope of the standard for receptacles. All right, so terminations are very critical, and from an NEC perspective, that would be, now remember my glasses are over here. Oh boy, I had to bookmark this because they changed their website. All right. If you go to 110.14, 110.14 is on terminations, right? 110.14, 110.12. So, connections of conductors to terminal parts shall ensure mechanically secure electrical connections without damaging the conductors. That's in 110.14a. Talks about connection by means of wire bending screws or studs and nuts have upturned lugs or equivalent shall be permitted for a 10 or smaller conductor. Just looking. Yep. So this receptacle, this is a see-through or a transparent receptacle, but it shows you right here on the termination, you see that there's a little tab right here that you can take off and separate the top from the bottom, but that also works to help you guide that conductor in there and wrap that around this lug. And so the what would you call it? The challenge is to make sure that you can wrap a conductor around there without deforming the receptacle itself, because that's connected to the blade where you're putting in your plug, and you want it all to hold. You want the proper tensions. All right, so 110.14 gives us guidance on proper terminations when you are dealing with screwed, or if you're using the wire connectors. You have the temperature limitations in 110.14c. Termination provisions of equipment for circuits rated 100 amps or less or marked for 14 through 1 American wire gauge conductors shall be used only for conductors rated 60 degrees C. Conductors with higher temperature ratings, provided the ampacity of such conductors is determined based upon the 60 degrees C ampacity of the conductor size. So there it is. That's in 110.14 C1A2. So that A2 is the code reference that would let me put a 90 degrees C insulated conductor and land it on this terminal. But I must use the 60 degrees C column of table 310.16. Conductors with higher temperature ratings, if the equipment is listed and identified for use with such conductors, is another opportunity, and for motors, etc. So let's see what else we got in here. Separate connector provisions. Separately installed pressure connectors shall be used with conductors at the ampacities not exceeding the ampacity at the listed and identified temperature rating of the connector. So And then you've got your torque. That's 110.14d is torque. Tightening torque values for terminal connections shall be as indicated on equipment or installation instructions. So we identified earlier, I did not find any torque information on this. Larry Griffith says switching under load such as lights, computer, printer, game station, small window, fan, or AC or ceiling. So here's the thing, Larry. If you see something that's marked not for switching under load, I don't think you're going to see a receptacle marked that way, in my opinion. Not one of these receptacles. And how many receptacles do I got? This is a quiz question. Oh, David Engelhardt. He is a 498 Technical Committee member. Thank you, David, for your contributions to the electrical industry, buddy. If you're on standards and codes, you are making the world a better place. Hopefully, if you're making the right calls. But Larry says, okay, so here's the thing. So, David and others, how many devices? How many receptacles do I have here? 1 or 2? That's a quiz question. Put it in the chat. 1 or 2, and once I see a bunch of responses, we will answer that question. But there's nothing on this device that will tell you not for disconnecting under load that I can find. They have the hot wire, they've got spec grade. What else do they got here? Made in USA. You've got the UL stamps. You've got the is that CSA, I think? I think it is. Got the manufacturer's name. Screw catch. This is the for the cover in the center. I don't see anything on this device that says not for disconnecting under load. NHZX boy 7. All right. Fred says 2. David Engelhardt says 2. David Engelhardt says a duplex receptacle outlet. This is a duplex receptacle. It's a duplex receptacle, and I will just tell you that I'm getting a phone call. I'm going to close that. That there's not 7. This is not 7. There's not 7. This is just 2 receptacles. 2 receptacles on 1 yoke, and that is the yoke. All right. So this is 2 receptacles. And then if I break the tab on the side, so if I break that tab, you'll see this one has a nice piece of plastic in between the 2, and you'll see that that plastic has a loop up to capture the conductor. And there is a tab right here that if I break that tab off and I break this tab off, then I have 2 single receptacles on 1 yoke. I can switch the top one on and off from a light switch, and I can use the bottom one as always being on to plug in whatever it is that I don't want to switch on and off. And then what you would want to do is once you break those tabs, you would want to, on the faceplate, say which one is switched, right? And I know some contractors, here's what some contractors will do. I learned this recently. I was doing a class, and we had the debate in class about, ground pin down or ground pin up. And the one electrical contractor told me that his practice is, for his company, that all of the ground pins in a residential dwelling unit, all the ground pins are down, except for when they have a switched leg or a switched receptacle, they put the ground pin up, and the top one is switched and the bottom one is not. Or if it's completely switched, it doesn't matter. If they switch both sides, then they will put it up and they will both be switched. but in their practice, they can identify very easily which receptacles are switched just by looking at the ground pin. Now, that's not standardized, that's not in the code, that is purely based upon the desire of the electrical contractor. All right, so I'm not going to settle the argument here, ground pin up or ground pin down, completely personal preference. There are no code requirements. Hey, Joseph Ioli, there are no code requirements that tell you the pin must be up or the pin must be down. What I have learned is your commercial and industrial guys and gals that are out there like to put the ground pin up. The residential wire people out there are like to put the ground pin down. I don't know why. I had an industrial guy tell me the reason they like to put the ground pin up is because if they have a plug that's somewhat pulled out, anything that falls down this way will hit the ground pin. And if it was this way, it's going to go straight across hot and neutral and cause arcing. But in residential dwelling units, we have AFCI protection. So the AFCI protected circuit would catch that. So in any case, but that was all I have to say about that. All right, so how about some other my links I've got? There are dimensional specifications. So if you go to click on the one link that talks about the wiring devices dimensional specifications, it's WD6. You can get a free download and accept the download standard. It will start to download, and it is working through that process. This document is going to give you some dimensional information on the wiring devices. Now, dimensions are critical for what? If I am going to have a box and I need to do box fill calculations, things of that nature, right? So let me open this device. Tells you where my head's at. I'm going to open this document. All right. Hopefully you can see that. So this is NEMA WD6 2021 edition. Let's take a look at the outline. You have marking symbols for automatically controlled. So we just talked about that. If we have an automatically controlled device, let's take a look. This is in part 5. Marking for controlled receptacles. Look at that. You have a symbol, and I believe there is a code requirement for that as well. You have the dimensional requirements. Tells you the dimensions from all the different aspects. If you're going to make faceplate covers and things like that, this is what gives you the rectangular faceplates. Tells you how the center to center lines and whatnot, so that if you want to make your own little plates, you probably can. And there are manufacturers out there that make decorative plates, right, for covers. There's your light switches. So these are all of your dimensions for these devices. You know, I call these rabbit ears, the ears on the device. This is where the screw that holds it into the box, and then you have the center screw for where you're going to put your faceplate. And if you have one of these, you have the center screw, but if you have one of these, you don't, right? So in the aspect of, for these types of devices, the faceplate goes over top, and then you have these two holes here up at the top where you would secure your faceplate. So important for that. So this has all of the different types of dimensions for your devices. So great resource for you to download. Here's another one, another resource for you. This is the protection of receptacle outlets in wet locations. And you can download this one. And There is your joint NEMA conduit fittings and outlet switch boxes. White paper protection of receptacle outlets in wet locations in accordance with the NEC. So this is probably based on the 2020 code because it's published in 2021. So, but these are all the different companies that are involved. So great resources for you. These are your, your heavy duty bubble covers, right? That you would find on the outside of a house or in any of those applications where you would see when you have an outdoor receptacle. So you might see these in parks, and you'll see outdoor receptacles everywhere. So many different locations. You have your cover plates, you have your box hoods, your gaskets. Look at that extra duty outlet box. You've got your gasketed. This box is gasketed, so you want to, and this is a standard receptacle. And I'll tell you, you know what I did on my house was I put the GFCIs on the inside of the house, because remember, say this is a GFCI receptacle. The GFCI receptacle will protect anything that's plugged in to the front. And because you have on the back line, up here it says line, down here it says load. So you come into your circuit and you come out in your circuit. This device will provide GFCI protection to any of those conductors and any receptacles that are downstream. So you can take a device like this and put it in the house or inside the structure outside of the weather, which will help these last longer, and then feed standard receptacles on the outside of the house. And a standard receptacle has no moving parts. So the only thing you've got to think about here, except for the tamper resistant, right? So the tamper resistant, I'd say it's a moving part, it's a shutter once you get the receptacle in there, but those are plastic. They do have some metal springs, but you put them in this type of an enclosure, and you're going to limit the exposure to the environment just because you've got gasketed fittings around, and you got to make sure that it's properly connected and you have the cover that comes over top. All right, so all of these good things of protecting the conductor, protecting the receptacle, okay? And then you have the general color requirements. Gosh, oh Neds. Just these are general color requirements for wiring devices. If you're familiar with wiring devices, you'll understand that these things come in like a cream or a white. Look, there's two different colors. And depending upon, I mean, this one's brown, for goodness sakes, okay? Hopefully, when you move into a house, hopefully someone in the family doesn't say, I wish the receptacles matched the color of the wall. That's a lot of work. So in any case, this one gives you color information. Ivory, white, gray, brown, red, yellow, black, orange. And then there's your Munsell notations. Okay, so receptacles come in many different colors, and you may elect for aesthetic purposes, or you may elect a specific color for the application, like in a healthcare environment. You might see a red, or you might see, I think blue. Is blue in there? No, blue's not in there. You got brown, red, yellow, black, and orange. You might see an orange receptacle to indicate certain things inside for the application, right? All right. So these give you the standards for the colors. So did I miss one in there? Then there's the hospital grade receptacles. And there's a link down in the chat box, or not the chat box, what would you call that? Down below, up above, or whatever devices. All right, so don't forget the WR ratings. Oh, that's right, Fred. So there's WR. So I've got, this one has a TR. Okay, that has a TR. That's tamper resistant. I don't know that I have a WR. That guy, if it had markings, it's not there anymore. I don't have a WR, but WR, weather resistant. So those are important for the proper application in those types of applications outside. Hey, Nick. Nick's on. Nick Cheeto, you finally caught live. Yes, Nick, you're here. We've been waiting for you all these years, Nick. And finally, you made it, buddy. Thanks. Willie Snyder, happy Tech Tuesday. A bit of tribal knowledge. Yes, good afternoon. Late today, Joseph. Dupless receptacle device, David Englehart. Jody Wages in the house. Larry Griffith. Nick Cheeto, I guess. We finally caught you. Yes. They do have it in standard duplex. TR for all living areas. Yes. So let's do this. Let me show you something. All right. So I'm going to go back up. Let's talk about codes and standards. UL 498, attachment plugs and receptacles. We know that. We know National Electrical Code, NFPA 70, and NFPA 70. I'm going to grab my 2023 code book. My 2023 code book. Right there. 406. I'm going by memory. 406, does that sound all right? 406, yes. 406.3, receptacle ratings and type. 406.3, 3G, receptacles with USB chargers. A 125 volt, 15 or 20 amp receptacle that additionally provides Class 2 power shall be listed and constructed such that the Class 2 circuitry is integral with the receptacle. Bam, 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 integral. Whew. All right, 406.3F, controlled receptacles, all non-locking type 125. This is 406, Article 406. This is .3. All non-locking type 125 volt, 15 to 20 amp receptacles that are controlled by an automatic control device or that incorporate control features that remove power from the receptacle for the purpose of energy management or building, blah, blah, blah. They have to be marked with the symbol, which we saw the symbol earlier, and it has to have the word controlled. And I don't have a receptacle. Some receptacles have it, but honestly, I'd break the tabs and it doesn't say, does it say? It says, shall be permanently marked. So it does say, it says all non-lockable type 125 volt, 15 to 20 amp receptacles that are controlled by an automatic control device or that incorporate control features that remove power from the receptacle for the purpose of energy management shall be permanently marked with the symbol So that first paragraph indicates that it has to be on the receptacle. Let's read the second paragraph. For receptacles controlled by an automatic control device, the marking shall be located on the receptacle face and visible after installation. Boom. You know what that means? You know what that means? You can't put it on the nameplate. You can't put it on the faceplate, the cover, and say controlled. It has to be on the receptacle. In both cases where a multiple receptacle device, this is a multiple receptacle. Multiple, two, duplex. The required marking of the word controlled and symbol shall denote which contact devices are controlled. Because remember, I can control the top and not the bottom. All right, so Article 406, you'll find a lot of really good stuff in Article 406. In 406, you've got reconditioning, you've got receptacle ratings, you've got Kolar, copper, aluminum receptacles, receptacle terminations, information about the terminations on receptacles. You've got the isolated ground receptacles, equipment grounding conductor that is required when it's an isolated equipment grounding conductor, installation in non-metallic boxes, how to do that, controlled receptacles, receptacles with USB, general installation requirements in 406.4. You got the grounding type, you got the methods, connection to equipment grounding conductors, you've got replacements, grounding type receptacles, non-grounding type receptacles. Oh my goodness. Receptacle orientation. You would think ground pin up or ground pin down would be in 406.5G, but all it says for receptacle orientation, it says receptacles shall not be installed in the face-up position or in countertop surfaces or work surfaces unless listed for countertop or work surface applications. So don't put them this way. Why? Water intrusion. Come on. Under sinks, receptacles shall not be installed in a face-up position in the area below a sink. So, think about it. These devices, as simple as you would think, they're pretty complicated. So, you've got a lot of requirements in 406. CSA C22.2 is your general use receptacles, attachment plugs, and similar wiring devices. That's the Canadian standard document that governs the performance requirements for receptacles and attachment plugs. You have federal spec WC596. This is your general specification connector, electrical power. Interesting. I'm going to see if I can do this. No, I can't. I don't know why it does that. Anyway, NEC 2023 defines a receptacle. Oh, the definition of a receptacle. Definition of a receptacle. That would be R, Tom. You would have to go to R for receptacle. So here is what the definition of a receptacle is. A contact device installed at the outlet for the connection of an attachment plug or for the direct connection of electrical utilization equipment designed to mate with the corresponding contact device. Now, this is your two prongs. Those are your two prongs, right? So there's your two prongs and a ground. But in some cases, if you're over like in Europe or you're over in some other countries, you're just going to see this, the receptacle, this is the plug. The receptacle would have to receive just these two pins, and then the ground is up here for that one. Other countries may do think this one doesn't have the ground pinned on it. So other countries, there, this one, that's a different, that's a lot different. Look at that. All right. That's different countries. Okay. So depending upon what country you're in. And then there's this guy here, which it's round. Okay. So it's round. All right. So a single receptacle is a single contact device with no other contact device on the same yoke. So what's the yoke? The yoke. I'll look at this old one. It's really clear. There's your yoke. That's that middle part that goes around the device. Okay? That's your yoke. These two receptacles are on one yoke. And that's important to know. A multiple receptacle is two or more contact devices on the same yoke or strap. Okay? This is two receptacles. This is two receptacles. There's your strap right back here. Okay? So, two receptacles on the same. Now, and why is that important? when you see a code requirement that says it has to be on an individual branch circuit supplying a receptacle, you see the language that says a receptacle. That's not one of these. This is a 2 receptacle or a multi-receptacle. We call them duplex or 2. These are 2 receptacles. Nick, huge fan of putting definitions in Article 100. Yes, is there a specification for orientation of switched receptacle in a dwelling when used in lieu of a luminaire? Orientation, no. No, there is not. You're permitted, like in a bedroom or in some of these rooms, you're permitted to switch a receptacle anticipating that a light will be plugged into it. But there's no orientation saying that if you use a duplex and you separate those tabs, then the top is switched, the bottom is not, or the bottom is switched, the top, nothing like that. Because, Nick, the requirements in 406 tell you that you have to have the device itself has to be marked controlled receptacle with the symbol, and it has to indicate which one is being controlled. If only one is being controlled and the other is not, it's going to be on the receptacle. And when you remove the face plate, when you remove the cover plate, it's going to remain on the device. You can't put the controlled aspect or identification of which is controlled on the cover plate. Got to be a part of the wiring device. All right, a multiple receptacle. So we talked about that. A duplex receptacle is an example of a multiple receptacle. All right, and then you have a receptacle outlet, and that's when you have an outlet that receives one of these, right? A receptacle outlet is the box in the wall. All right. All right. Let's look down. While not prevalent, there are non-metallic yokes. So a yoke is not always going to be metallic. In 210.7, here's another reason why. Multi-wire branch circuit, 210.7. Let's take a look at 210.7. 210.7 tells us, if 2 or more branch circuits supplying devices or equipment on the same yoke, so 2 or more branch circuits, so this would be a duplex receptacle, 2 receptacles on the same yoke. I break the tabs in between the 2, so I put one branch circuit feeding this one, another branch circuit feeding that one, okay? 2 separate. So multiple branch circuits, if 2 or more branch circuits supply devices or equipment on the same yoke or mounting strap, a means to simultaneously disconnect the ungrounded supply conductors shall be provided at the point at which the branch circuit originates. So I have to be able to disconnect those ungrounded conductors together. Disconnect the ungrounded supply conductor shall be provided at the point at which the branch circuits originate. Okay, and you're probably going to label those correctly. Porcelain light, Richard Smith. Porcelain light socket is considered a receptacle. A porcelain light socket. So I think what you're talking about is when you have those porcelain light, like that receives the Edison-based bulb, and there will be a receptacle there that you can plug something into. Well, it's technically a lighting outlet. And the lighting fixture, the lighting, not fixture, the lighting, we don't call them fixtures anymore. The luminaire has an integrated receptacle. But it's not a receptacle outlet. Still, it's a luminaire, it's a lighting outlet. It's not a receptacle outlet. It's a luminaire, Richard, thank you. The luminaire, boy, I tell you, I had a hard time. I had a brain freeze. So, but you have the receptacle that's built into a luminaire. Capiche? Capiche. Okay, so 210.7. What else? 220. Doop. The term yoke is used 20 times in the 2011 code. 498, we already mentioned. Retention of blades. So some of the criteria that we list in some of the tests that we perform, we have the blade retention. I think Robert from Omaha, I think he mentioned blade retention. There's your blades. And I'll tell you what, the manufacturing of the blade itself is critically important. If you don't make the blades correctly, you're not going to get a good contact here. So there is a level of importance on proper blade retention. After 10 insertions that don't exceed 40 pounds of force of standard steel blade plug gauge, the receptacle must be able to hold or retain a polished steel two-blade plug gauge without holes against a 3-pound force for 1 minute. So they probably hang it upside down, they plug that in, they hang a 3-pound weight off of that, and it has to retain those plugs, retain the plug in the receptacle for 1 minute. The receptacle must release a polished steel three-bladed plug gauge with holes at no more than 15 pounds of force. So there are tests for the retention. And in NFPA 73, if you don't know what NFPA 73 is, NFPA 73, oh man, I hate this. They changed their website. Oh man, they don't make life easy anymore. It used to be really nice and easy. You just go there, click on it, and let me click on this. Anyway, NFPA 73 has some requirements around. I was going to give you the sections, but NFPA link is not easy anymore. You got to have the bookmarks in. So anyway, I'm not happy with NFPA's new webpage, but anyhow. So blade retention, current overload. To pass this test, the test sample device is subject to 100 insertions and removals of a mating plug, making and breaking DC current through a resistive load at 150% of the device rating. The blade of the attachment plug is to mate with the contact of the receptacle for not more than 1 second during each cycle. They do a temperature rise. After all of those overload tests and the blade retention tests, the same examples, same ones, are subjected to a temperature rise test. Strategically placed thermocouples help to ensure the test subject passes the test, which requires that the contact temperature rise of a flush or self-contained receptacle cannot be more than 54 degrees Fahrenheit or 30 degrees C when the receptacle is carrying its maximum rated current. So they test these at its maximum rated current. So it's a 15 amp, 15. If it's 20, it's 20. Repeat blade retention. They do a resistance to arcing. That's pulling it out under load. They have a terminal strength. They have grounding pin retention. They have fault current. For this test, now, all right, subject to a through fault current of 1,000 amps downstream of so I wrote this a while ago. This was before I learned. So it says, I put on here when it's downstream of a 15 amp or a 20 amp circuit breaker, and that is not true. The UL tests for short circuit. The UL tests for short circuit. Robert from Omaha. So what I learned was the actual tests are performed not downstream of a circuit breaker. They are performed downstream of a fuse. The short circuit tests, like on a GFCI, there is a practical application guide a PAG, and the circuit for testing these for short circuit test, show you. They don't test them downstream of a circuit breaker. They test them downstream of a fuse. That's how they do the short circuit. That's how they do the short circuit tests. They don't test them with circuit breakers. I don't know how many of these devices you actually see downstream of a fuse. Probably not that many, especially in a dwelling unit. But they test those with a 20 amp K5 fuse. This one is the ground. So the ground is, there's a 1 amp fuse in the ground. That's for safety and whatnot. But this, they don't put a 20 amp circuit breaker in the testing. The line fuse shall be a 20 amp type K5 cartridge fuse rated 250 volts, an NON20 or a Farad-Shama type OT20. The fuse shall be secured and suitably rated, blah, blah, blah. So in any case, the short circuit test, there is a short circuit test, but it's not done with a circuit breaker downstream. It's done with a fuse upstream. So in any case, there are short circuit tests. There's a dielectric with voltage withstand test. There's a mold stress relief. Unwired receptacles are subjected to 7 degrees C for 7 hours, and after being allowed to cool, measurements are made where there shall not be any warping, shrinkage, or other distortion that results in the device not performing as expected. They do a dielectric voltage withstand, and then they do an assembly security. The test is quite grueling, and that the subject receptacle must endure a 50-pound force through extra long blades inserted into the receptacle and directly on the back of the receptacle. Dadgummit, man. Beat it up. They have hospital grade, has to go through an abrupt removal. They have some additional testing for hospital grade. Federal spec product performance. They have gripping power blades, terminal strengths, overload, 200% overload. They have additional tests for Fed spec. And then they have the tamper resistant. And then you have all the different types of ratings for these different receptacles. So receptacles, in my humble opinion, receptacles have come a long way. In technology, we have surge receptacles, we have GFCI, AFCI receptacles. We have receptacles that are round. We have to make sure that we apply them properly, install them correctly. We don't want this stuff going on our receptacles. I don't want to receive stuff like this in the mail ever again, because I want you to properly torque these things down and make sure that we're installing them correctly. We've covered a lot, and we are 1 hour and 15 minutes. Richard, thank you. Nick, finally, buddy. Finally, we get you online. We were waiting for you. Thank you for joining. Thanks, everybody, for joining. It's been over 1 hour. I've got a flight to catch tonight, heading down to Texas. And hopefully, everybody out there has a great rest of the week. I appreciate you dialing into these 1 hour tech talks on IAEI News Live. And I hope to see you next week again on IAEI News Live so that we can chat about a different technical topic, or maybe a little bit more of a deep dive on receptacles. I don't know. We'll figure it out. Thanks for tuning in. Thanks for what you do for electrical safety. Thanks for what you do for the electrical industry. And Fred, remember to stay safe and please stay healthy. See you next week. Until we meet again, take care. God bless.